Thank you for the introduction, and I'm very excited to have this opportunity to present here. And what I'm going to talk about today is dynamic pricing for parking. But actually, I'm going to talk about dynamic pricing. But when you want to know is that how do you actually apply that to the industry? So I will talk about that for parking, which is the industry we provide software and service for. So before I get started, I would like everybody to take 30 seconds to think about what do these businesses have in common. All right, so I'll give you my answer, and we'll see if your answer is the same as mine. So for all this business, you invest in assets upfront, and you rent them out by slices of time, right? So take hospitality, hotels, for example. You invest in this hotel building, the rooms, and then you actually rent them out by slices of time. Cloud computing, you have tons of servers, computational powers, you rent them out by slices of time. And parking is actually very similar if you own a parking asset, like garages, like parking lots, or for cities, the curb. You actually rent them out by slices of time. And not only these, so you can think about all the share economy cases that this is also the case. Uber, Lyft, Airbnb, WeWork, and then all the scooters and bikes that you see on the street these days, they are actually all running a business very similar to this. And what's the ideal scenario for business like this? Right? So you actually, because you already invested in the asset, you want to use them as much as possible. So for example, if you're a hotel, if you have an empty room for the night, then that's actually loss of revenue for you. And for parking, it's similar. It's more extreme because if you have empty space for an hour, that's loss of revenue. So the question is, how do you actually keep your asset very, very much utilized? So the most obvious and most effective lever you can pull is the price. So for example, if you're running a hotel in Hawaii, then you will probably charge more during the Christmas because that's your best season. And even if you raise your price a little bit, you will still get a full hotel. So you will actually want to increase the price. In that case, you actually capture a lot of value during the peak season. And on the other end, you want to reduce the price when you are not on the peak season, right? You want to stimulate the demand. So for people who wouldn't consider you before would actually suddenly able to afford and then will actually utilize whatever asset you invested in front of the time. And however, this process is not as simple as it seems because you can charge $1 million a night for a hotel room and then you probably get a ghost hotel, right? You can make it free for a hotel. And then you'll probably have a full hotel every day, and you are not making any money. So what is the best price in that spectrum? That's the interesting problem about dynamic pricing. And before I talk about how do we do dynamic pricing, I want to show you some numbers so that you might think, okay, so this could be important, and then we should actually care about this. So I listed 3 industries here: airlines, hotels, and parking. So for airlines, the number in 2015 is that they estimate that the dynamic pricing actually provide an additional $9.27 billion additional revenue to the industry. And the estimate is that it could top $20 billion a year in 2020. For hotels, the industry standard these days is that the estimate is that they actually increase the revenue by somewhere between 5 and 7%. And the hotel industry is about $200 billion a year industry in the US. So that accounts for about $10 billion. For parking, there's not many people actually doing dynamic pricing these days for parking. And from our estimate, which is not just coming out of nowhere, but the thing that we actually run and piloted, I will show you the results later, is that we estimate there is an additional 10 to 15% gain that you can actually get from dynamic pricing. And parking is about $30 billion in the US a year, and that accounts for somewhere between $3 to $5 billion potential. That's totally untapped. So now is the fun part. How does dynamic pricing work? Right? So this is the basic chart of Economy 101, right? So the y-axis here is the price. X-axis is the quantity, right? And you have the solid line, which means if you have a higher price, you have a little bit lower quantity. When you have a lower price, you have a higher quantity, right? So you can think of your price as a slider on this line that you have control. And what you want to do is that you want to maximize the area below this point, which is simply just the revenue, which is the price times the quantity, right? So you want that area to be the biggest. There's a caveat, though, because the curve can actually change, right? It could change every day. It could even change every hour because, for example, in the peak season in Hawaii, you will actually have a higher curve because when you are charging the same price, there could be still more demand, right? And that is why this curve can actually change. And then it could be a little bit tilted. It could be a little bit flat. It could be moving up and down. And that is what dynamic pricing is about, is to figure out or approximate that curve and then figure out what is the price that can actually give you the most revenue. That's the most basic, simple idea that how dynamic pricing works. However, as you can see, there are a lot of empty spaces under the curve, right? So other than the revenue, there is a lot of space above the dashed line. Those are the people who can actually afford more, but you are not charging them more. There are also people on the right-hand side of the dashed line. Those are the people who just cannot afford your price. How can you capture more value? You can do product differentiation, right? For example, if you have a hotel room that has a beautiful ocean view, you can charge a premium, right? Then you capture that additional revenue from the people who are willing to pay a little bit more, but for a better experience. And if you have a hotel room facing the yard, for example, you can just charge the regular rate. If you have a room that's facing the back alley with a dumpster, then you probably charge a little bit less, and then some people might not mind, and then they can actually pay a little bit less for that. So you can see you actually capture more area under the curve, and then you can actually get more revenue. Of course, there's another side, right? You can do user differentiation. We all heard of the horrible story about how if you are using iPhone, they actually show you a little bit higher price than when you are using desktop or Android. And for us, we actually consider that unethical because you are actually selling exactly the same product just because how people actually access your price. What we want is that if you are actually charging people more, at least you should provide better service or a better product. So now get back to parking, which is the area that I know. So how do they do dynamic pricing today? So this is, we have about a little bit more than 2,000 locations in our system at this point, and these are the best cases scenario. So some of our clients, they basically spend a week and pull the report from 10 or 20 different places, put them together, analyze the report, and then they sit down all in the room in the day and then say, how do we do in the past quarter? Is our weekday demand going up or down, right? If it's going up, we might be able to increase it by a little bit. Is our weekend rate too high? Maybe we can drop it a little bit and then more people will come. And after that day, they put the price in place, and that's the price for the next quarter. And then after the end of that quarter, they will do this all over again, right? So basically the quarterly review leads to the price change. And some of the municipalities also do this exercise, but some of them only do like once in a year, if they do it at all. So the title of this slide is How Could AI Help? Which is, the AI here is the buzzword, but in essence, I mean, how do you combine mathematical models, computer science, together with software engineering to actually make this dynamic pricing better. So there are several steps. So first of all, you can do a continuous prediction. For example, yesterday, Halloween, right? So we actually see some of our clients have a surge of parking transactions just because they're in downtown and there's probably a parade going, or there are some events, and a lot of people just go over and park. Those are the things that you could potentially predict based on all your historical data. So with this continuous prediction, you can know, okay, so the demand is probably going to be high, and I can actually adjust the price accordingly. But that is not enough, because there are a lot of events that you cannot capture. So for example, if I own a garage in this building, and then there is a conference going on next door, or there's a corporate training in the next block, then I can actually see, for the online booking, there are originally 50 people book ahead of the time every day, but now there are 200 people booking. And then you know something is going on. And then from that, you can actually recognize the pattern, and then you can actually adjust the price in minutes, not months. So in that way, you actually shorten the cycle, and then you can actually react to the market change or unforeseeable scenarios very quickly. Because as well as we want the prediction to be, we know that the prediction, especially for human behavior, you can probably go to 80%. If higher, it's actually starting to become creepy, because how do you know whether this person is actually going to park at this place, right? So you can only get somewhere, and then with the real-time monitoring, you can do even a better job. And you can shorten the cycle, and then you can do it very quickly, and then take human out of the loop. They don't have to spend a week just to actually review the numbers, which is the best done by computers. Okay, so it's all talk. Now I want to show you some results from our pilot project. So we work with some of our industrial partners to actually try this dynamic pricing, and we did it back in July. So we tested 4 locations in downtown Chicago, 2 locations in New York City, Manhattan, 1 location in Boston downtown area. And the result that we got is that for the Chicago locations, the revenue we estimate went up for about 18%. And for the New York location, it's up by about 11%. And for the Boston location, it's up by about 8%. To give you a little bit more sense, I'll show you 2 charts. So these are for our Chicago locations. So the x-axis here for the curves is the day in July. And then the y-axis is the revenue. But I'm hiding the numbers because I cannot show the exact revenue numbers here, but I can give you a little bit order of magnitude. So for all these locations, there are the annual revenue that they get is in the tens of millions of dollars. And what we tried in this pilot project is to dynamically adjust their price for online business, right? So some people actually book parking online, and that accounts for about somewhere between 10 to 15%, depending on which location we are talking about. So that's the order of magnitude we are talking about here. And there are 3 lines here. So I don't know whether you can see it clearly, but there is an orange line in the middle. That's what our results are. So those are the numbers when we are running our pilot project that we actually achieve. There's a blue line, which is the bottom line. That's if they actually kept their own pricing, how much would they get day by day? And there's a green line, which is the optimal pricing. What that means is that if we had known the demand ahead of the time, how can we price, and what's the best result can we achieve? But of course, we cannot know, right? Because we are adjusting the price ahead of the time rather than after the fact. So we cannot actually achieve that number, but that number provides a good estimate of the potential. So what's the best we can do? And as you can see in this chart, our number is actually up by about 18%, and then the optimal we estimate is 48%, which means that we can actually do better in our models, in our math, so that we can actually bring it up maybe to 30%. There is a lot of space to improve. For this chart, This is the two New York City locations. And their revenue is in the high millions a year. So similarly, 3 lines, but in this chart, you can probably see that for dynamic pricing, our number is up about 11%. The optimal pricing, however, is up for about 15%, which means we are pretty close to the best we can do. Of course, the locations actually differ from each other by a lot. So we actually see the numbers all over the place. So even some locations that are just 1 block away, they are actually exhibiting very different behaviors when you are adjusting the prices. Because the physical locations, for example, sometimes even the entrance actually make a very big difference, whether the people can actually find it, whether people can actually easily locate it. And there are a lot of different kind of characteristics of what's going on in parking. So before I wrap it up, I want to also show you what about in the public side. So the picture here I put is a real-time and historical parking number mapping for city of Santa Monica. So what they want is that they want to achieve an ideal of 85% to 90% occupancy, especially for on-street. A reason is that they want the utility to be high enough because they want people to actually use the parking there, especially by the curbside. But in the meantime, they don't want it to be full because then people circling around on the street over and over again, causing traffic, causing pollution, and that's a less than ideal scenario. They want to use dynamic pricing to achieve an ideal occupancy. Also, they want to encourage the turnovers, which is a little bit different from the private sector, right? So for the private sector, if you park for a long time, they're happy, and then they probably give you a discount. The longer you park, the cheaper per hour rate you will get. But for them, it's different because they want people to actually not hogging the space for a long time, right? So you actually want them to just park there, do their thing, and then leave. So for some cities, if you park more than, let's say, 2 hours or 3 hours, the hourly rate actually goes up so that you do not have the incentive to park for a long time. And for some cities, like San Francisco, they just don't allow you to park more than, let's say, 2 hours or 3 hours outright. Also, they want the transparency for the public, so they want to actually show the numbers for the public so that the public will understand, okay, so I'm increasing the price for this particular period because it's all full, and you don't want people to circling around on the street. And during this period of time, for this district, we see that there are not many people parking here, so we can actually lower the price. And then the last item is, of course, revenue increase. They will be secretly happy about a revenue increase. They wouldn't tell you because their top goal is not that. But when they make more money, they are happy. So this is the takeaway. Several items that I want to summarize. So pricing is at the core of business with the fixed assets rented out by slices of the time. And we're actually seeing more and more of this, especially with the shared economy. So I can guarantee you that in the near future, you probably will see the dynamic pricing for all the bikes and all the scooters. When you actually want to use it during the daytime, the price will be very different from when you want to use it during the night. Because that's actually at the core of this business. You want high utility rate. You want to adjust the price to achieve a good level of revenue. So how could AI help, right? What AI here could help is that you can facilitate, you can shorten the cycle, that you react to the market conditions. You can do that in minutes, right? Even in seconds if you want. But you can do that in minutes rather than in months. And then you can actually do that and then keep the human beings out of the cycle because humans are very prone to errors, right? When you have to pull 10 different reports and then put all the numbers together, you make mistakes. And you can actually save people a lot of time. So the last one is that there's a huge impact on the revenue. Right? There are billions of dollars that could potentially be, additional dollars could be made if you are doing dynamic pricing. And I want to emphasize here that this additional dollars is not just by increasing the price and make everything more expensive, but to actually utilize your asset better, right? You can actually lower the price and then it's used by more people. And those people will be happy because they pay a little bit less, but you will actually utilize your space, which you have already invested upfront. And then you can actually make more revenue as well, right? So this could be a win-win situation. So I want to emphasize this additional revenue you can make is not just by squeezing the last cent out of everybody. Okay, so lastly, I'm from SmartKing. So what we do is that we provide parking analytics software and service for people who care about parking, typically cities or parking asset owners. For example, if you own a garage or you are a real estate owner, you have a building with a garage. Those are the target people. And also we target the parking operators who run the garages. So for me, I graduated from, my background is called operations research. It's mostly applied math. I always wanted to apply this software engineering skills and data science skills in the traditional industry because I believe there's a lot of value in the traditional industry. I never thought I would end up with parking, but I actually am very happy where I am right now because it seems very unsexy from the outside. And that's exactly why there is a lot of opportunities. And there are actually very challenging data science and data engineering problems that we're trying to solve. And that's actually a very interesting and very exciting time. That being said, I'll wrap it up here and see if anybody have questions.
In the couple of examples you gave, I was just curious. Do you guys capture the timing in which the revenue went up? I mean, I'm relating it to when did the customer know about the new price? Did we even give him an option to turn back? So if I'm going to my work, I have no option. I have to pay them money on this spot.
Right. So in the cases, so our pilot, we actually only do online, right? So you actually book ahead of the time. So when you are actually booking, you already lock in the price. So you are actually aware. So you don't have to say like, oh, I'm here, and then now suddenly the price goes up, and then I don't have an option. So it's actually online.
One thing, if the next speaker is in the room, if you could come up, I'll plug your computer in while he's answering questions. Sorry about that. Go ahead.
Yeah.
So while you are providing that new price, new dynamic pricing, they also show the trend of what it is during other times of the day for better information for the customer.
So do you mean the occupancy numbers for?
Right. Say for example, I'm planning my trip and I'm going to be there at 9 o'clock.
Mm-hmm.
Your dynamic pricing shows like $3 per hour or whatever. And do you show that okay, if you were to go by 9:45, your price is going to go up or down?
Yes. So you can. So the question is whether you will be able to query the pricing for different time span. Yes. So. The partners that we are working with are providing the online booking services for customers, and then you can actually query. So let's say your target time is like 9 to 4, and maybe you will be there 9:30. So you will also check whether 9:30 actually is as a better price. That's right. So Spot Hero and ParkWiz, those are the two biggest ones.
Only one observation from my side. AI. Easy to apply, easy to deploy, but to develop that particular concept will take at least 4 to 6 months. Saying that, it's very easy, the way takeaway is.
Yes. So the point here, the question is that, of course it looks easy here, but actually developing the concept, testing it, and making it into production, it takes months. And that's absolutely true. And yes, so it's not easy. You need the right infrastructure. You need the right team to support. You need the right partner to do this with you. So it's not easy.
This information is very key because there are people who are not a data scientist. They are the business guy, you from you, and expect the data scientist to deliver.
That's right. Yes. So yes, obviously, I should have mentioned that this is not just, you just plug it in 1 month and you get everything, right? There are so many preliminary conditions you have to satisfy, right? So we went into this business, and for 3 years, we don't get the clean data, right? Finally, we get the clean data, because without the clean data, you cannot do the pricing right. It's basically garbage in, garbage out, right? So you need to get the clean data. You need to actually understand the concept. You have to test it out, because different industries have different results, right? So you have to do the pilot project, and then you have to measure it. That's not just a simple effort. Thank you for pointing that out.
Let's say if I'm a regular user of your parking lot and your prices keep changing regularly, what happens to my trust in your business?
Yeah, that's a good question. So if I'm a loyal customer to let's say this particular garage, and the price actually changes all the time, how would I actually react and adapt? Yes, so a lot of our clients, they actually have a royalty program. So if you actually come here very often, they will actually provide you a special rate, right? So that's the royalty program. And also, if you actually come very often, then maybe the monthly parking pass actually makes more sense to you, right? Because if you actually just buy a whole month, it might cost you like way less than if you actually pay day to day. So there are different kinds of programs, and that's what I was talking about before. Like you can slice and dice. You have different users, and then you provide them different services, and then you can actually charge them differently. So we have the model, right? We have the model measuring. We have the elasticity curve model out, and then we would actually say, okay, so after the fact, we actually have this much demand at this price point. So how do we, if we knew this is the curve ahead of the time, we already have the calibrated curve after the fact, what would be the best price? That's how we actually measure it, and then give an estimate. Of course, by no means it's accurate, but at least it gives us a sense like how big the gap is. All right. Thank you very much.
All right. Thanks again.